Hello everyone, we are solving a problem from photoelectric effect in this video lesson. The problem is like this. A metal of work function 4 electron volt is exposed to a radiation of wavelength 140 nanometer. What is the corresponding stopping potential is? That's what we are supposed to calculate. First of all, energy of the photon is utilized first to release the electron from the metal surface called work function. Remaining energy will help the electron to move from one side to another side, and it's called kinetic energy. When we apply a reverse potential V, which is equal to W by Q or W by E, we are doing a work against that kinetic energy that is equal to VE, which will stop the electron to move from cathode to anode. That particular potential is called stopping potential. So Einstein photoelectric equation can be written like work function plus instead of kinetic energy you can write EV naught, where E is the charge of the electron and V naught is the stopping potential. And in this problem, you need to calculate that stopping potential itself. Being work function is already given as 4 electron volts. If you know the energy, who is equal to h nu, as wavelength is given hc by lambda, we can solve the problem. So we know the value of this h, we know the value of the c, we know the value of the lambda. But if we convert that values back in terms of, say, if you substitute the value of the h, c, and if you substitute the value of the lambda in terms of the, say, angstrom, if you will get a calculation like 12,400 by substituting the lambda in angstrom will give the energy in electron volt. That can be calculated. We can just calculate that. So the incident energy of the photon E in electron volt is 12,400 by lambda in angstrom, that is 140 nanometer or 1400 angstrom. Calculating this will give you a value like 8.86 electron volts. So from this equation we can write 8.86 electron volt is work function 4 electron volt plus EV naught. This electron is common in all the equations, can be cancelled. So 8.86 volt equal to 4 volt plus stopping potential. So it's obvious that stopping potential will be 8.86 volt minus 4 volt. That's nothing but equal to 4.86 volt. That means if you apply a reverse potential of 4.86 volt in the given scenario, though the electron gets releases, it's not capable of reaching from cathode to anode. That's how we need to solve the problem, where we can use this simple equation to make the calculation little easy. To remind you back, if lambda is in angstrom, you can get the energy in electron volt by using this formula from this hc by lambda as 12,400 by lambda in angstrom has to be substituted. That's it. Thank you for watching. Keep coming back for more and more video lessons. Thank you.